Okay. Couple examples left. It says factor the greatest common factor such that the remaining factors have only integer coefficients. This should be, I screwed up, that should be 2x squared, by the way. My bad. Okay, so it says factor the GCF so that the remaining factors have only integer coefficients. Meaning I need to factor out this 1/2 right here. That's essentially what they're telling me, is that there's a fraction in that problem and I need to factor that fraction out. So my GCF would be 1/2 x. And look at what happens if I factor out a 1/2 x. Well, if I divide each of these terms by 1/2 x, I'm going to end up with 1x squared here plus, well, if I take 2 divided by 1/2, that's like 2 times 2. So 4x. And then minus 5 divided by 1/2 is 10. So that's basically what it means when it says factor out the greatest common factor. I don't know why that's writing up there, but I'm going to go on to the next slide. I have to figure out what's left over. Basically, I need to divide each term by 2x. So I'm going to end up with 3x squared minus 2. Because there was an x, but now it's gone. So there's my final answer. Essentially, when you're factoring, you're trying to figure out what was being multiplied together to get the polynomial that I started with. And so you can actually check every factoring problem. If you go back through and multiply this together, you should end up with 6x to the third minus 4x. If you don't, then something went wrong. All right, so that's GCF, and that's the first thing you should always look for. Example 2, another type of problem that you guys factored in Algebra 1 was called a difference of squares. A difference of squares. And this occurs anytime you are subtracting, so it's only subtracting, 2 perfect squares. 2 perfect squares. Anytime you're subtracting 2 perfect squares, you can do this factoring method that we're about to do. And so I notice here I am subtracting, and these 2 terms are perfect squares. So here's how we factor this when this happens. We are going to take the square root of each one of the terms. So the square root of 9x squared is 3x. The square root of 4 is 2. And so I take the square root of both, and now I'm going to do 2 things. I'm going to add those 2 terms together, and then I'm going to multiply that by the subtraction of those 2 terms. So anytime I'm subtracting 2 perfect squares, I take the square root of each term, and I add them and I subtract them. And if I would go through and multiply this back out, I would end up with 9x squared minus 4. All right. Now, this part's new. You have not seen this yet, okay? We've always talked about difference of squares. We've never talked about cubes. And so there is a formula if you are subtracting or adding with cubes. It actually works with addition too. There's a formula. And so I'm going to write this down here. And again, this is in the book as well. So let's say I'm subtracting 2 cubes. Let's say I have u to the third minus v to the third. And I want to factor that. So I'm subtracting 2 perfect cubes. Well, here's the formula for that. I'm going to take the cube root of each term. So u and v. And I'm going to start by, well, the first sign is going to be whatever the sign is in the polynomial. I'm just going to subtract the cubes. So u minus v. So I take the cube root of each term and I subtract them. I'm going to multiply that by, well, I'm going to square the first cube. So u squared plus, I'm going to multiply the 2 perfect cubes together, u and v. I'm going to multiply them together. And then plus, I'm going to square the second perfect cube. So this is when I'm going to factor a difference of cubes. Notice the signs. If it's a difference of cubes, the first sign is subtraction, second sign is addition. Because now look what happens with sum of cubes. Let's say I'm adding u to the third plus v to the third. Okay, so now the only difference, well, 2 things change. It's going to be u plus v. And over here it's going to be u squared minus uv plus v squared. So notice the difference here. Since it's a sum, The first sign will stay the same. The second sign alternates. The last sign is always a plus because you're squaring that term. And if you square it, you're always going to get a positive. All right, well, let's do an example with that. So I want to factor 8x to the third minus 27. Okay, so just like with the squares with cubes, I'm going to go ahead and take the cube root of both. So 2x and 3. Those are my two cube roots. And so I'm going to look up here at the difference of cubes. So I'm going to take those two things and subtract them. It's going to be 2x minus 3. Now in the other set, I'm going to square the 2x. That's what the u squared means. So 4x squared. It's going to be a plus sign. Next, I'm going to multiply these two things together. Forget about the sign, but just the 2x and the 3. So 6x. And then plus, I'm going to square the 3. So basically, everything I'm doing has to do with the cube roots of both those numbers. And after you factor a difference of cubes or a sum of cubes, there's nothing else I can do. I can't factor this thing anymore. So that would be my final answer. That one will take some getting used to. You'll practice it a little bit in the homework, but hopefully it's not too bad. Okay, this next one should be kind of second nature. Factoring x squared minus 7x minus 30. This is the one we probably spent the most time with in Algebra 1. If there's a quadratic trinomial, quadratic because it's x squared, and trinomial because there's 3 terms, and the leading coefficient is 1, meaning it's just x squared. This is the one where you find two numbers that if you multiply them, you get the c term, and if you add them, you get the b term. Remember, it's always ax squared plus bx plus c. So I need to find two numbers that if I multiply them, I get negative 30, and if I add them together, I get negative 7. So you need to start thinking of factors of negative 30 that would add up to negative 7. And hopefully you come up with those two numbers being negative 10 and 3. And so in parentheses, I will do x minus 10 times x plus 3. Again, that's the one we probably spent the most time on. All right. Well, now what happens if you have a quadratic trinomial and you have a number other than 1 in front of x squared? Well, you probably learn this multiple ways depending on your teachers. I know a lot of teachers use guess and check, meaning this. You'll put parentheses. This is what a lot of you learned, I think. And I know my first terms, here and here, have to multiply to be 5x squared. I know my last terms have to multiply to be negative 6. So like negative 2 and positive 3. But here's the deal. Remember, if you multiply the middle terms and the outer terms, the sum should be 13. I didn't know the answer to this and just plugged these in, and it actually worked. So if I notice, this becomes negative 2x. Over here becomes 15x. And if I add those together, I do get positive 13x. So everything worked out. My first terms multiplied to be 5x squared. My last terms multiplied to be negative 6. And the inner and the outer terms, if I multiply them, the sum is 13x. That I didn't mean to actually put the answer in my first try on that one. So let's say, for instance, I tried this first. 5x and x. And let's say the last ones I made plus 1 and negative 6. Because the first one's multiplied to be 5x squared, and the last one's multiplied to be negative 6. Well, now if I multiply the middle ones, I get 1x. And the outer ones give me negative 30x. If I add those, I don't get 13x. So I know that's wrong. That's the wrong factoring. So the middle and the outer ones need to add up to 13x. So it would have been that first one I started with. It would be 5x minus 2 and x plus 3. Another way some of you might have learned, I'm going to show this kind of quickly because some of you may have learned it this way. I know we taught this in Algebra 1. So if you had me for Algebra 1, this will be more familiar to you. I don't know how to erase this any better. Or quicker, I should say. But we called it the AC method. What the heck? It's not erasing. Well, I'll just do a new screen with it, and do an example of that again. 5x squared plus 13x minus 6. I don't know if this recording is, since I'm going back and forth, I'm not exactly sure what's happening here. But I'll do the other couple examples. Hopefully I'm not talking over myself. I'm kind of confused right now what's going on, since I jump slides back and forth. I'm getting used to this stuff. All right. So it says factor completely. And so what this means is always look for the GCF first. But first of all, I'm going to rearrange these terms. So negative 2x cubed plus 2x squared plus 4x. And I'm going to factor out a negative 2x. Forget it. I'm going to go on to a new slide and just redo those examples. I think I'm talking over myself. Group 2, I could pull 3 out. And what should happen in this method, you should always end up with the same thing in the parentheses here. And so your final answer, you take one of those sets and put it in one set of parentheses. And the other set are the two terms on the outsides, the GCFs you took out. And you can factor every single one that way as well. Some of you might remember doing that. Some of you don't. If you don't remember that, it's not a huge deal. Okay, I'm going to start that back here because I think that was kind of confusing. So it was 2x squared plus 4x minus 2x cubed. I'm going to rearrange these to put it in standard form. And I'm always going to look for the GCF first. So I'm going to pull out a negative 2x. So I'm going to have x squared minus 1x and then minus 2. Sometimes you could take out a GCF, and what's left over you could factor even more. Always look for that. If you factor something, always look and see if your remaining factors can factor even farther. And so if I notice here, I have a quadratic trinomial. I can find two numbers that multiply to be negative 2 and add up to be negative 1. And so that would be negative 2 and 1. So my final answer would be bring down the GCF, and I would have x minus 2, x plus 1. Right there. And the last example is 16x to the fourth minus 81. It's going to be your job to recognize what type of polynomial it is and then how to go about factoring it. So I noticed that I'm subtracting two perfect squares. So I'm going to take the square root of both of these, 4x squared and 9, and I'm going to add them, and I'm going to subtract them. But sometimes you factor and then you could factor more. And so if I notice in here, I have another difference of squares right here. I'm subtracting two more perfect squares. This one can't factor anymore because it's addition. So I know that's going to be in my final answer. But the other one, I could take the square root of both of these, 2x and 3, and now add 2x and 3 together and subtract them. So sometimes you could factor and then factor more. If that recording went over myself and you didn't hear a couple of things, let me know. I'll try to clarify that. I'm not exactly sure what happened. But this is a whole lot of factoring stuff in one section, but that is why this is called the prerequisite unit. A lot of these skills are skills we should have coming in, and now this unit is just kind of re-going over all that stuff fairly quickly. If you need an AL pass, if some of this factoring stuff didn't make sense, please come down to AL. We'll take a look. If you want to look at the section and some of the examples before you do that, feel free to do that as well. But after you watch this, you guys can go ahead and start your assignment.